Okay, this is our last video that we have on training the simulated scan of a composite panel. Okay, so we'll pick up where we left off. We've got our data tiles loaded, and we've got our labels on them. The label is basically the number of indications that's in that tile, so you can see it's sort of 0, 1, or 2 typically. And then we've got these split up into training and validation sets over here. Okay, so for the Python code, I'm just going to drop my code in here. I'll do a paste. And I'm not going to go through all the training of the neural network and so on. I'll just look at the InspectionWare part. And that basically comes down to this bit here. So the training data set, I've got up here, remember this one, get IW object with no argument is just going to be our Python node. We go up one to get the training data set, and then we go get data object, and this gives us a data buffer, which is essentially a Python array. And 0, 1, 2, 3 corresponding to 0, 1, 2, 3 data sets there. So training and test buffers. You do need to load the data. That's probably worth knowing in this, and we're going to convert it to floating point. I don't think you actually need that in this case. I think that data is already floating point. And then basically you get them into a NumPy array. So we've got the NumPy arrays here. And I think that's it for the InspectionWare code. The rest is fairly boilerplate TensorFlow stuff dealing with dimensions. My network is pretty simple, but it's basically based on a 64 by 64 input. Okay, so I'm going to drop out a diagnostics window, which is going to be my trace for my Python. And let's clean that up a bit. Remember, you need to do console to get Python to show, and run this and hope it works. And there we go. So we're running 20 epochs, and I'll just pause. Probably take a couple of minutes to run. I don't have the GPUs running at the moment, so it's a bit on the slow side, so we'll just wait for that to run. Okay, so the model has trained successfully, and it's saved as findflaws.h5. So that's what I've saved my model as. This is, pretty simple, so it's hard coded. So I'm going to go over to my training tree. So the training tree is one of the 32 original fake scans we made. We break it up into tiles, and then these are going to get classified as to whether they have flaws or not. So put that away for now. So I'll again drop my Python code in here. This one's pretty short, and it's pretty much, I think, okay, sorry, that looks like the training code. I'll replace that with the prediction code. That looks right, and again, that's the model we saved, and the data set is going up to this guy, and then in this case we just get the tiles out, and we just run it, and we'll see what happens. So So the output there is a bunch of numbers, I guess the weight of the expectation that there's a flaw in that tile. And the deconvolved tiles is complained, and it's complained because it needs the reference data of the tiles, and I think that's going to run. Okay, and so we'll just drag this out, and I think I'm going to split my window in two, and I'll put my original data up there and the deconvolved tiles down there. That's not a useful palette. I'll flip it over to grayscale, and basically what that's telling us is it's sort of put the weighting of the tiles into the space of the original, the shape of the original data, so you can see that it's getting the pattern. There's a couple up there, there's one there, and if you look through it, it doesn't match too badly. There's a bunch down here. The annotations don't look right on that, do they? I think they might have gone, oh, it's probably mixed up from loading another data set, but it doesn't matter too much. We're looking at the flaws. Anyway, I think that's good for this video.